Hi everybody, I'm going to be doing the homework help video for the third exercises in Scilab, your favorite programming platform. Okay, let's start with number 1, I guess. Solve for the root of f of x equals x cubed minus 7 over x plus 2 between 0 and 2, using the bisection method with the tolerance of this. Well, okay, you guys, let's open up Scilab. I'm going to go ahead and post the scripts I wrote in the video on Canvas, so you guys can download them and look at them. Sometimes people get stuck on a syntax error, and I'm sorry, but you can compare and contrast. I recommend that you program your own anyway, but you're going to be modifying it. Sure. Okay, so this was the one I did last time. So first thing I'm going to do is change the function. It's not the video function anymore. It's like x cubed minus 7 over x plus 2 minus 7 dot over x plus 2. Okay, so I'm going to go ahead and execute this. Execute this guy. Let's go here. Now, let me re-execute it. I didn't put it on the desktop, and I always usually do that. I think it'll still work. So, like, if I type in y equals f of 0, let's do f of 1. Negative 4 f of 0. This might actually be bad because it's infinity. Ooh, that might be a problem in the code. So, let's go back here. If I put in 7 divided by 0, I get an infinitely big number. So, this is actually infinity. Infinity. So we might have to, in the code, that might be a problem in the code. It might not be able to work. So it's positive infinity, but we'll see if it works. If it doesn't work, we'll just put in some number like close to 1, 0.1, for example. Oh, it's actually negative infinity. I can't read for some reason. Negative infinity. Anyway, probably still work, right? Have some faith. So the bisection method should work now. I've got to change my upper bound and lower bound. My lower bound is 0, my upper bound was 2. And my tolerance is, there's 4 zeros in there. So I should be able to run this now. Run away. Oof. I think it worked perfectly. That got my graph up. There's my root. If I look at my information over here, it took 20 iterations to get there. There's the history. So the first one was exactly in between 0 and 2, which was 1, then 1.5, 1.25. So this is the history of the boundaries. So we know that it's somewhere between these boundaries. And my answer ended up being 1.43, like, there's my answer right there, 1.4269543. So I'm just going to copy all this stuff right here, Control C, and place it where does it want it? I'll put the root value. This is going to be the history. So I'm going to cut that and paste it right in here. There's the history. Oof. I don't want the ABCD crap. Oops, snipping tool. You can actually snip it away if that's easier, but here's my history, right? C. And paste. Text only. Okay, the rest of this stuff you can type in. It's cut and paste. You need the function, which I did. Just copy and paste the function. The bisection script, which you can just type in. What iterations needed? It looked like we needed like 29 of them. Right? So this is how you do the first one. I'm just going to stop cutting and pasting here. It actually asks you to plot the first 5, so you're going to have to put in a pause. How would I do that? So go back to your Scilab script. Go down to the bottom of the while loop and type in a pause. Actually, mine's already got it in there, so I'm just going to uncomment it. We run that code. Well, first, let's close the graphics window so we can get a new graphics window. Okay, so now we're going to run it. So there's the first one. I'm going to type in the word resume into my window so you can see the graph as it's happening. I'm just going to drag it and make this a little smaller. Okay, so resume is going to make it whoosh. If you look over here, it's on iteration number 1. And it just made a second point. I have to get like 5 iterations of this. So I'm going to do this, hit resume a few more times. By the way, what does this mean, the X? The X means that the lower bound is moving up. Diamond means the upper bound. So I know the root is somewhere between here and here. And on the next one, let's do like one more of these. Now, this one that's halfway is the upper bound, so I know the root is somewhere between these two. And let's do it once more for the first 5 iterations. So there we go. There's my first 5. So now I can just grab my snipping tool. Just drag that whole thing. There's my graphics window. Edit, copy. You can save that as a JPEG and import it into Word. I just like to copy and paste. So there's my 5. Now you have to comment on which direction the new bound is being assigned. So what's happening every time I pause, right? So, I know this is going to sound weird. If I go back here, I can actually write on here a pen. Which way is it going? It's going this way if it's circles, this way if it's X's. So I can actually type in X's. Wow, that's real bad typing, but with a mouse. And this is diamonds, actually. There's my diamonds. Diamonds. Apostrophe. So the diamonds are moving in this direction, and the X's are moving in this direction. So right now, there's my root somewhere in there. Is my root. It's my perfect circle. Something like that. Now I know this sounds weird, but edit, copy. And let's delete this and paste in the new one. Look at that. All done. So I comment, I mean, you should write a sentence in here as to what's happening. Basically how this technique works is the midpoint between upper and lower bounds is tested to be positive or negative. If it's positive, it assigns it as the new upper bound. Else, otherwise, if it's negative, it's the new lower bound. the picture below looks at the first 5 times this happens. The diamonds represent the upper bound and shift to the left over several iterations. The X's represent the lower bounds and shift right over iterations. Isn't that cool? I answered my question. Now, I know this sounds weird, but like, can I make this smaller and have it all fit on page? I'm kind of a stickler. I guess I can always edit this later, but I like to get everything on one page. Here's another. I'm not going to copy and paste stuff, but like, look how nice this looks. Do I get extra points for doing this nice? No, I should do it nice because I can, and turning in nice work is good. So I've answered number 2 there. So number 3 and 4 are kind of the same thing. You have to do a golden section method. So instead of halfway, you have to modify the bisection to get it 61.8%, not 50%. So if you think of the midpoint as 50% between the upper and lower bound, you want 61.8% between them. So in your line of code, let's go back to bisection code. I'm gonna make this big for a second, but maybe that's too big. I don't want it. I don't like it big. Let's go look for where it halves it. Where does it make the new bound? Bisection halves the interval as the next guess, right? So new bound is upper bound plus lower bound times a half. Another way of writing this, which would have worked real nice, instead of dividing by 2, you could have multiplied by 50%. And that would do the exact same thing as divided by 2. How would I change this so that it's going to do a golden section method? Change that number right there from 50% to 61.8. Run the code and see if it converges faster. I know it sounds weird, but like, the golden number is everywhere in nature. And believe it or not, even in these mathematical functions, it's actually generally better at finding the root. Like the iterations are generally less in number. It saves you more calculation power if you do a golden section method than if you do bisection method. Bisection method for some functions takes a real long time to figure out the root, whereas so we are interested in sort of optimizing our work. What would be better than doing percentages? So that's the question. That's the last question you have to think about. How would you figure out which way is better? So we'll pick that up from next time. But here's your help video on kind of the expectations for what you need to type in. So I know a lot of people are struggling with the code, so I'm just gonna post the code, my code on there. It's a little bit easier. Should I just try to do the least amount of work possible in my life? Sure, but at the same time, you want to be learning how to code, so I would recommend you recreate your own code. You might find an easier way of doing this. Or just learn more from like debugging. Debugging actually helps you learn quite a bit. So if you type in and you forgot to, divide by 2 or something, like it helps you learn how to do that. So failure is not the worst thing that can happen to you. You just have to learn from your mistakes. All right, you guys.